Hi everyone. So welcome to another video where we're looking at hypothesis testing on correlation coefficient. So here we're told that the relationship between two variables is presented in the following table. Test at the 10% level of significance whether there is any correlation between the two variables. And we're given x and y, and we need to determine whether there's any correlation. So in this type of question, you always want to start off with the null and the alternative hypothesis. So the null hypothesis would be that there is no correlation, and the alternative hypothesis is that there is correlation. We have not been asked to test whether there's positive correlation or whether there's negative correlation or whether that is statistically significant, only that whether there's any correlation. So as long as it's different from zero, and that's why I've gone for a two-tailed test. And I'm going to do a sketch here. So that's going to split the significance region into 5% and 5%. So once you see not equal to, we know that it's two-tailed, and the significance level is 10%. Two-tailed will split that into half. All right. Now the sample size 1, 2, 3, 4, 5, 6. So n is equal to 6. So we look for n equals 6. Then we will look for 5% or 0.05. So do make sure that you print off the formula sheet or the data sheet for your exam board, and then go through that data sheet very carefully. Make sure that you're really familiar with it. So you should be going through your data sheet, and you should be looking for the critical values for correlation coefficient in your data sheet. Your exam board would have provided you with that. So here I'm going to look for n equals 6, and then I'm going to go across to 0.05, and I should get 0.7293. So my critical value will be 0.7293, 0.7293 negative. So as long as I get a value for my correlation coefficient that lies between this, then I will not reject H0. I will only reject H0 if the absolute value is larger than 0.7293. So I'm going to now go to my ClassWiz, and I'm going to go to statistics, and I'm going to go to option 2, which is y equal a plus bx. All right. And then I'm going to enter the x values and the y values. So x 30, 40, 20, 22, 29, 19, and then the y corresponding y values are 90, 75, 70, 73, 80, 76. I'm going to save that by pressing AC to save data, and then I'm going to press option OPTN, and then after I press option, I'm going to select number 3, regression calculation. All right. So once I've done that, I've calculated R to be equal to 0.344 to 3 decimal places. All right. So in this question, there is an implicit task that is also being placed upon us, which is to calculate the value for R. So until we calculate the value for R, we won't be able to complete the hypothesis test. So here R is equal to 0.344, and clearly 0.344 lies inside the acceptance region. Therefore, we're going to accept H0, or if you want to be technical, we are going to not reject H0. All right, so do not reject H0. So again, how would we complete our conclusion? We would say there is insufficient evidence at the 10% level of significance to support the claim that H0 is different from 0. All right, and that should satisfy the demands of the question. Now, some of you might have the FX9850 GC+, and I think the options should be quite similar in terms of calculating R. So let's just go through that. Should be similar to your CG50. So if we go to statistics, and then we go to, so it will bring up table. Make sure list 1 and list 2 are cleared. So you will delete everything in list 1 and list 2. And then we enter list 1 as our X. So 30, 40, 20, 22, 29, 19. And then we go to list 2, and that will be our Y, 90, 75, 70, 73, 80, 76. All right. And then here, go to calc. Then you're going to go to reg, R-E-G, and then X. All right, so that's calc, reg, and X. And then you should see R equal 0.344 to 3 decimal places. All right, and you can explore, you should be using a similar set of menu options for your CG50 as well. All right, so hopefully that was helpful, and then wait around for a few more examples on this topic.